Hello everyone. In this short video, I'm going to show you how you can distinguish between these functional groups: hemiacetal, hemiketal, acetal, ketal. Suppose, for example, you're given the structure of a molecule and you're told it belongs to one of those four categories. How do you tell which? Well, the first step is to find the carbon that's directly attached to two oxygen atoms. That carbon we'll call the central carbon. We'll also call it the head carbon. And you want to mark it. Now, in our example here, you can see that this carbon is bonded directly to the two oxygens here. This is the central carbon, that's why I have a red star. Now, next look to see if there is an OH group bonded to the starred carbon. If there is, it's going to be a hemispecies, either a hemiacetal or a hemiketal. To tell which, here's what you want to do next. Go back and look at the starred carbon. If there is a hydrogen directly attached to the starred carbon, it's going to be a hemiacetal. It is here, the hydrogen attached. Now, if there is no hydrogen directly attached to the starred carbon, if it's only carbon groups, then it's a hemiacetal. You can see here that there is no H directly attached to the starred carbon, only carbon groups, so it's a hemiketal. All right, now suppose there is no OH bonded to the starred carbon. There would only be, that is, O carbon groups. It is going to be an acetal or ketal. How do you tell which? Well, go back, look at the starred carbon. If there's at least one hydrogen attached to the starred carbon, it will be an acetal. So in this example here, there's a hydrogen attached to the starred carbon, therefore it's an acetal. If there is no H directly attached, that is, if there is only R groups bonded to the starred carbon, it's going to be a ketal. That's how you do it. Well, let's next try this out with some examples. Okay, let's look at this molecule first. Find the central carbon. Find the carbon that's directly attached to two oxygen atoms. All right, it's obviously going to be this carbon, so let's start it. Okay, the next thing we want to do is to determine if it's a hemispecies or not. Look for the presence of an OH attached to the starred carbon, and indeed there is right here. This means it's going to be a hemispecies, either a hemiacetal or hemiketal. To tell which, we look at the starred carbon again, see if there is a hydrogen, at least one hydrogen directly attached to the starred carbon. Indeed there is right here. All right, this means we have a hemiacetal. Hemiacetal. All right, let's look at the next example. All right, find the central carbon. All right, in this structure, it's part of it is a bond line drawing. Look for the carbon directly attached to two oxygen atoms. That's this carbon right here, so put a star there. All right, is this a hemi species or not? Well, is there an OH present? If there is, it's a hemi species, but you can see clearly there is not. No OH. This must mean that it's a full-fledged acetal or ketal, right? To tell which, look at the starred carbon and see if there's a hydrogen attached, at least one hydrogen. And there is not. If there were, this would be an acetal, but there's not. There's only carbon groups attached there. Therefore, this is a ketal. Oh, by the way, because it's part of the ring, we call it a cyclic ketal. Cyclic ketal. All right, let's do the next example. All right. Find the central carbon. Let me ask you to think along with me. So find that, put a little asterisk on it. Okay, that's this carbon here, directly attached to two oxygen atoms. Is it a hemi species or not? Well, look for an OH. Indeed we have an OH. This means it's a hemi, either a hemiacetal or hemiketal. All right, look at the starred carbon and see if there's at least one hydrogen attached. If there is, but there's not. And so this means it's going to be a hemiketal. Right, hemiketal. Now the last one is, well, it's my favorite. This is an interesting compound. It's naturally occurring galactose. Galactose is a monosaccharide that belongs to a family called aldohexoses. One of the more familiar members of aldohexoses is glucose. Both glucose and galactose are aldohexose compounds. All right, well, let's proceed. Now this one might seem to be a little trickier because there's oxygens and OH groups all over the place. Don't let that get in your way. Look carefully and find the head carbon. Carbon directly attached to two oxygens. Well, let's see here. Take a look. Would this be the head carbon? The answer is no. It's not directly attached to two oxygens. It is this carbon. This carbon is directly attached to this oxygen and that oxygen. So that's our central carbon. All right, let's determine if it's a hemi species or not. Is there an OH directly attached to the starred carbon? Yes, right here. So it means it's going to be hemiacetal or hemiketal. To tell which, see if there's at least one hydrogen directly attached to the starred carbon. And there it is right here. The starred carbon is bonded directly to this carbon atom here and directly to a hydrogen. Being the hydrogen directly attached to that means that it's a hemiacetal. Hemiacetal. And there it is. Because, by the way, it's part of a ring, this is a cyclic hemiacetal. Cyclic hemiacetal. Okay, hope that clarifies things. Thank you for watching.